Alrighty, so we're going to go ahead and start spring damper part one. To do this, of course, we'll first start by making a new model. For this one, I'm going to name it spring damper. So make sure it's part one. Your global Y is what the coordinate system you want to set, and this is what you'll want to have for your units, the MMKS system. So then we'll hit OK, and of course you'll want to choose where you want us to save to. I don't really care for this one, so I'm just going to do it there. Okay, I'm going to go ahead and make this full screen just so it's easier. Get this out of the way. All right. So for the first part, we're going to want to make a rigid body. I'm going to create a square block for this one. It's not too important what the length is, but essentially what I'll want to do is click over here, and for my purposes, I'll do a 5x4. So 5 by 1, 2, 3, 4. And again, not too important what the size of that is, but this is the way that it tells us to do it in the tutorial. So then we will want to right click. I then want to make sure that it's on the part. We'll go to part 2 and then modify. And then of course what I want to modify is to make our mass defined by user input. And then I will choose make it a mass of 187.224. And that's just so that our numbers will match the textbook. Okay, so once we're done with that, we'll then want to constrain it. So I would recommend doing this by first rotating our whole frame. You'll kind of want to make it match this. I'll just kind of wiggle it in there. And then I want to zoom out on this too, just to make it easier for me, but you don't have to do all this. All right. So then after we're done with that, we're going to want to add a joint. We'll do this by going to connectors. I want to create a translational joint. This is the one that it will bounce on essentially when we have our spring in there. So then I will want to keep all of this, 2 bodies, 1 location. And then I will want to select the rigid body. So it's going to say part 2 is going to pop up like that. And I'm going to click on part 2 as our first one. And then ground, you'll see that pop up and you'll click ground as your second one. Okay, so then we'll want to select our location, and we will make our location the center of mass, which is that part2.cm. So then I'll just go ahead and click center mass, and then we'll want to select the orientation. And to start, again, not super important, but we'll want to make sure that it's going up, right? And there should be a direction vector here. Yeah, that's it. Okay, so then we can actually click on the cm.x, and it will be going perfectly in the, I believe it's the x direction. Yeah, so perfectly up in the x direction, which is what we want. And then it'll give you the box for the joint. So it's a good visual representation of that. And then to make sure that this is working, we can go to simulation, and we can run an interactive simulation. And it's going to go kind of quick, but it will show us that it is working. And then we can see our box fall, and it's falling perfectly in the extraction. So that is a good way to test this. All right. now we will want to move on to moving it to our working grid. So this part will bring essentially this grid that you see in the back, we're going to move it to our center of mass. Now we're going to do this by going to settings, working grid, and then I'm going to go ahead and then we'll go ahead and want to set our location. I'm going to go ahead and select pick, and then we will pick the center of mass, and again, it'll say part2.cm, and then of course it'll move it, hit apply, and okay. And that is how we move our working grid. So now we're going to want to add a predefined spring damper. We'll do this by going here. As we can see, under flexible connectors, it has a translational spring damper, excuse me. We're going to want to go ahead and select this. Then for our properties, we'll select both K and C. We want to set our K value to 5 and our C value to 0.05. Or for whatever project you're using, you'll want to set these to whatever spring you're using. We're then going to go ahead and choose the part 2 CM, and we're just going to want to drag and go up. So we'll fix this in a minute, but we'll go ahead and do that. You can then right click on it, go to spring, and then go to location. Oh, we have to right click on the ground, excuse me. So what we'll actually want to do before we click anywhere is we will want to right click, and then we will get this box that pops up called location event. We're then going to want to set this to 0, 400, 0. And then we'll do this relative to the origin because our working grid, or actually, sorry, we'll do this relative to grid because our working grid is our origin. Well, and then we'll hit apply, and it should give you a spring damper, which is perfectly 400 millimeters. Okay, so then we want to verify that it is actually at that. We'll go to tools, we'll go to measure distance, double click on this, and then it will give you our first position. We want that to be our center of mass because that's of course where our bottom of our spring damper is. Second position, we'll then want to go to our marker 5 most likely. And then we'll go ahead and hit apply. And as we can tell, marker 5 actually happens to be at the origin. This probably isn't right. This is a very common issue. The book actually tells you to click on marker 5, but does not appear at the right parts. So my guess is that marker 6 in this case is actually the correct one. We'll go ahead and hit apply. And of course, we'll see that it's at that 400 millimeters. So in this case, marker 6 is the correct marker. Hit OK. We'll just go ahead and close out of this. So now we'll actually want to find the force in the spring damper. We'll want to find this at equilibrium. We'll do this by going back to our simulate. We'll run an interactive simulation. Makes this easiest. We'll then want to select the static equilibrium tool, which is what this guy does. And of course, it'll tell me it's complete. Cool. What you can't see is up here, actually. It's telling me which direction it's in. And eventually it'll tell me a force up here too when we get to that. And we'll do that real quick by going to our settings, force graphics. I can find that. Force graphics, there it is. Okay, and then we want to hit display numeric values, then we'll hit apply. Okay, and as you can see, 1836 is our amount of Newton's force that this is being applied. And if you got 1,836 newtons, you are doing this correctly so far. All right, so now we'll go ahead and we can actually run it if you like. You'll see that it bounces, which is really cool. You can visualize that. Of course, if you hit our equilibrium, you'll get that 1836 again. And so, yeah, this is conclude part one.